The project, wire printing from column to truss, is inspired by the simple factory building in Singapore, in which the truss member gradually elongates and eventually becomes a vertical column. Here are some previews of the project, from diagrams to rendering and to wire printing. We hope to further the exploration of wire printing, which was first developed by a team at MIT in 2014. The MIT team pointed out two issues regarding wire printing. First, when the printer is printing a diagonal, the turning corner or edge will deform as the plastic is not cooled down before the next move. They solved the problem by varying the print speed during the edge. As we are not looking to print quickly, we decide to have an 8-second pause when turning a corner, so that the printed plastic is cooled before the next move. The second issue the team pointed out is the collision between the nozzle and the printed plastic. The printing path designed by the MIT team was optimized to prevent collision, but that limits the angle of the diagonals to be around 20 degrees. Therefore, we are modifying the hot end so that we can print diagonals that are steeper than 20 degrees and even print a straight column. We machine a stock volcano nozzle and make a nozzle with a pointy tip, then fit it on the hot end with an extra ceramic heating ring to ensure nozzle temperature. The pointy nozzle ensures the steep diagonals are printed without collision with the nozzle. The G-code is created with the grasshopper, with three major parts: the square, the diagonal, and the columns. The square G-code always starts and ends at the same point. The nozzle moves along a polyline formed by a list of points which equally divides the square perimeter. Then it returns to the starting point. From there, the G-code for the diagonal starts. The gradually changing height of the diagonals are regulated by the graph mapper component. When the nozzle returns to the starting point, it moves vertically to the starting point of the next layer of diagonal. When the nozzle finally reaches the column, it gets more tricky as the traveling path has to be added to avoid collision between the nozzle and the printed plastic. So the nozzle will print the vertical column, then retract to the top of the next column, and then descend to the starting point of the next column. As mentioned before, plastic needs more time to cool down. Therefore, between every movement, a pause of 8 seconds is added to form a node that better connects the hanging strings. These images capture the process of wire printing. There are many challenges. For example, the flow rate, bed temperature, and pause time has to be frequently adjusted. The printer configuration file has to be edited to make the Z end stop working together with the extra long nozzle. And at one point, the nozzle clogged. Yet, wire printing has been fun to explore. Thank you.